Hello, my name is Steve Bowler, and in this video we're going to be taking a closer look at Routing Information Protocol, otherwise known as RIP. Specifically, within RIP we're going to be taking a closer look at RIP version 2 and how to configure RIP version 2 on Juniper routers. So first we're going to go over the basics of RIP, why you would want to run RIP as your routing protocol, and why you would not want to run RIP. RIP uses what is known as hop count for its metric. So if we have a lower hop count, or less routers between a source and destination, then that path is going to be preferred over a path from the source to destination that has a higher hop count. For instance, between R6 and R7, say we had R6, R9, and then we had a router over here, R10, and then R7, and we advertise the 7 network into RIP. When this route got to R6, it has two paths. It has a path through router 8 to get to router 6, and then it has a path through R7, and then R10, and then R9, and then finally R6. Using the metric of hop count, the preferred path would indeed be the path between R7, R8, and R6. However, what you might see is that this is the slower link, because these are 1.5 megabit links, whereas at the bottom we have 100 meg links, are fast Ethernet links. So again, we have T1 at the top and fast Ethernet at the bottom. So that is one of the basic principles of RIP and how it calculates its best path to a destination in the network. And what I have created is I have 4 routers. We have router 6, router 7, router 8, and router 9. These routers are all simulated as logical systems within one physical router, and we're going to connect all of these routers together using logical tunnel interfaces. And I have abbreviated these logical tunnel interfaces. For instance, on R8 we have LT.87, and if we write this out in the full format, this would be LT-1/2/0.87. So you replace the XX with the actual unit of the logical tunnel. And if you're not familiar with logical tunnels, go ahead and watch my Logical Systems Lab 1, where I explain exactly how to set up logical tunnels. So the first thing we're going to do in this lab is I'm going to configure all these logical systems and all the links in between them. On router 6 we have a loopback 0.6 interface with the 6.6.6.0/24, and on R7 we have a loopback 0.7 interface with the 7.7.7.0/24 network. And then we have all of the networks in between. So for instance, between R6 and R8 we have the 86 network. The network between R6 and R9 is the 96 network. The network between R9 and R7 is the 97 network. And the network between R8 and R7 is the 87 network. So what we're going to do in this lab, we are going to advertise the networks on R6 and R7, the loopbacks, into RIP. We're going to take a look at the RIP metric in detail, and we're going to manipulate the RIP metric accordingly. So let's go ahead and start configuring RIP. Configuring the routers, the logical systems. So the first thing we're going to do is configure all of the interfaces on R6. So we'll do the command set logical systems R6 and then interfaces. We're going to use the LT-120. The connection between R6 and R8 is going to be unit 68. We're going to give it the IP address of, if we look at our network topology, the 86 network with the .6 IP address. Oops, sorry about that. Forgot the keyword address. 86.86.24. And then the other two things we need to finish the logical tunnel interface is the set logical systems R6 interfaces LT-120 unit 68, and then our peer unit, which is our binding between the two logical tunnel interfaces, the one on R6 and the one on router 8, and that should be it. So the next command is the encapsulation. We're going to set to Ethernet. So if you're not familiar with these commands that I'm showing you, again, I would review the Logical Systems Lab number 1, and that is where I lay a solid foundation for you on how to configure logical systems using the logical tunnel interface option. So the next thing from router 6 point of view, we're going to create the logical tunnel 69 interface. So unit is going to be 69, and we're going to give it the IP address of 96.96.96.6. with the /24 subnet mask. Our peer unit is going to be exactly the opposite of 69, so it's going to be 96. That is the router 9's unit, logical unit. Then our encapsulation is going to be Ethernet. So the last thing we're going to do on R6, we're going to create our loopback 0 unit 6 interface. I'm going to do that with the command set logical systems R6 interfaces loopback 0 for unit 6, and then we're going to specify family of iNet with the address of 6.6.6.6 with a /24 subnet mask. Let's go ahead and commit those changes. We're going to save the changes. And the next thing we're going to do, we're going to go ahead and configure router 7 now with all of its interfaces and connections to router 8, router 9, and its loopback. So first we got to create the logical system. So set logical systems R7 interfaces LT-120. From router 7's point of view, it has unit 78 and unit 79. Obviously 78 is going to be connecting to router 8. Again, we are using IPv4 throughout the lab. And our IPv4 address on the subnet between R7 and R8 is going to be the 87 network. Peer unit is going to be 87. Again, it's the reverse. It is router 8's logical unit. And we're going to specify under unit 78 the encapsulation of Ethernet. So that's a connection between router 7 and router 8. Next we're going to configure unit 79. and this is the connection to router 9 from router 7's point of view. And it's going to have the IP address 89.89.89. I'm sorry. I think that's 79. Let me verify. Sorry, I forgot exactly what the IP was. So again, 97. So inet address 97.97.97.7/24, and the peer unit is going to be 97, and the encapsulation is going to be Ethernet. Our last thing that we have to do on R7 for the initial config is do set logical systems R7 interfaces loopback 0. Oh, sorry about that. So loopback 0. The unit is going to be 7. Family inet with the address of 7.7.7.7/24. So we'll go ahead and commit that. And we're going to move right along to router 8. So set logical systems R8. Interfaces is going to be LT-120. And from router 8 we have a connection to, obviously router 8 being in the middle, we're going to have a connection to router 6 and router 7. So logical tunnels 86 and 87. So unit 86, that's a connection to router 6. The family is going to be inet with the address of 68.68.68.8/24. And the peer unit we're going to create is, the binding to is going to be 68. Again, that's R6. And the encapsulation is going to be Ethernet. So the connection between R8 and R6 is complete. Next thing we're going to do is unit 87. That's a connection between router 8 and router 7. Family is going to be inet. The address of, I believe it's 87. Let's go ahead and, it is indeed 87, so let's go ahead and put that in. So 87.87.87.8/24. Again, the peer unit is going to be 78. That's R7's logical unit. We're going to give it the encapsulation of Ethernet. So router 8 is complete. Let's go ahead and commit those changes. So as you can see, I like to commit all my changes after I configure each logical system. Everybody has their own preference. So let's go ahead and do logical system. Our last logical system, or our last router in this diagram, is router 9. Our interface is going to be the, again, logical tunnel 120. And then if we look at our network diagram again, we have logical tunnel 96 and 97. So 96 obviously going to router 6, 97 going to router 7. So unit 96, we're going to give the IP address of 69, I'm sorry. Oops, did I create? If you're looking at this and you saw that I put in 68, that is indeed wrong. I'm going to go ahead and change that in 1 second. So let's go ahead and change, let's create router 9 first. So 96.96.96.9/24. The peer unit is going to be 69, again that's router 6. And the encapsulation is Ethernet. Then our last connection from router 9's point of view is going to be unit 97. And that's going to be the 97.97.97.9/24 network. And this peer unit is going to be 79, again that's router 7. Encapsulation Ethernet. So let's go back to where we had the 68 IP. That is indeed wrong. So we're going to go ahead and change this to 86. Again, that is the connection on router 8. Easiest way to do this, we'll just do a quick delete, and then we'll go back. We'll do a set, and then we're just going to change the IP address from 68 to 86. So again, 86.86.86.8/24. So let's go ahead and commit. Go ahead and commit and quit. And now let's go ahead and start our pings. So the first thing we're going to do is let's do a ping from logical system R8. So from router 8's point of view, router 8's in the middle, we're going to ping the 86, we're going to ping R6, and we're going to ping R7. So ping logical system R8 86.86.86.6. That's router 6, and you can see that we have reachability to router 6. And then we'll do a ping to 87.87.87.7. And we have reachability to router 7. Next, let's go ahead and ping from router 9. We'll ping 96.96.96.6. Again, this is router 6. We have reachability to router 6. And we're going to ping 97.97.97.7. And we can see that that is successful as well. And that is the connection to router 7. Do a show route logical system R6. You can see that we have our loopback that we created on R6. We also have the links between router 6 and router 8, and also router 6 and router 9. Let's go ahead and check R7 real fast. We have our loopback that we created, and we also have the connection between router 7 and router 8, and router 7 and router 9. So everything looks good at this point. And the next thing we're going to do is we're going to go ahead and go over how to start advertising and how to set up RIP. And we're going to also explain why we need a routing policy when setting up RIP on a Juniper router. So the first thing we're going to do is on R6, let's go ahead and set up the RIP routing protocol. We'll go under let's do this. We'll do set CLI logical systems R6. So we're gonna it's acting like we are right at the command prompt at R6. We'll go into configuration mode and we'll do the command set. Again, to enable RIP on an interface, we're going to do the command set protocols. Then if I do a space question mark, you can see that we have the option for RIP. We'll do set protocols RIP spacebar and question mark. And then we're going to use what is known as a group. So we'll do the command set protocols RIP group space question mark, and it's going to ask us for a group name. In this case, we'll just name it RIP. If we do a space question mark, we have the statement asking us for a neighbor. Then if I question mark after a neighbor, it's going to ask us for the interface name for our neighbor. So from R6 perspective, it's going to have two RIP neighbors. We're going to advertise RIP on all of these interfaces, including the loopbacks. So logical tunnel 68 and 69, we're going to advertise into RIP from router 6's perspective. So the neighbor's going to be, we're going to have a neighbor off of LT LT120.68. Then we're also going to have a RIP neighbor off of LT120.69. So right now we have enabled RIP on LT68 and 69 from router 6's point of view. The next thing we're going to do is go to router 7 and do the same thing. But on router 7 we're going to advertise 78 and 79 interfaces into RIP. So we'll do a commit and quit. Then we'll exit out of there. Go back into, we'll do the set CLI logical systems R7. And now we are in logical system R7. We'll go under configuration mode. We'll do the command set protocols RIP. Again, the group option is what we're going to use. We're going to name our RIP group named RIP. Then we're going to specify our neighbors, our neighbor interfaces to peer on. From router 7, we are peering on logical tunnel 78 and 79. So easy enough, we just add in logical tunnel -1 to 78 and 79. Let's go ahead. We have router 6 and router 7 configured. Let's go ahead and configure router 8 as well. And router 8, we're going to have the logical units, or the logical tunnel units of 86 and 87. Let's go under configuration mode. We'll do the command set protocols RIP group RIP, then our neighbor to peer with. So again, this is just like we are advertising RIP under the interface, or advertising the, not under the interface, but advertising the interface into the RIP process. LT120.86 and 87. Let's do a commit, and then we'll exit out of configuration mode. To verify that RIP is running on the router, we can verify RIP by doing the command show RIP, and if I do a space and question mark, we have the statement for a neighbor. And we can see that we have the interface in which we are peering with a neighbor, the state of RIP, the source address that we are using for RIP, the destination address. And if you're not familiar with RIP version 2, or just RIP version 2 in general, RIP version 2 uses the multicast address of 224.0.0.9 for its updates by default. You can see that where it says send mode is multicast, receive mode is both, so it's going to be receiving and sending both version 1 and 2. Again, if you're not familiar with RIP version 2, RIP version 2 provides the following enhancements over RIP version 1. RIP version 2 allows for MD5 authentication, so you have some form of security within authentication to peer routers, whereas RIP version 1 is just plain text authentication. And also RIP version 2 allows you to send classless routing information. So it allows you to send subnets within your routing updates, whereas RIP version 1 does not allow you to do that at all. So that's one of the basic show commands with RIP. If we do show RIP stats, we can also get a very general high-level view of the stats running on all of the interfaces. So updates sent, received, and so on. And by default, we will go ahead and the next thing we're going to do in this lab, now that we have the link between R6, R8, and R7 configured with RIP, all the interfaces, let's go ahead. The next thing we want to do is we're going to start to let RIP advertise routes into the protocol and let other routers receive these routes. So by default, RIP will not advertise any of its networks to its neighbors. So in the Cisco world, all you would have to do is advertise a network in to the RIP routing process, and it will find and advertise neighbors using this network address, this network option. However, in Juniper, there's a little more configuration. It's a little more configuration intense, where we have to create a policy statement and add routes into the RIP process. So the routes that we're going to add into the RIP process under our policy statement are going to be from the protocol RIP and from protocol direct. So our directly connected interfaces we're going to advertise into RIP in this lab. We're also going to advertise RIP networks that we learned to other neighbors. Because by default, these properties are not, these networks are not advertised. We have to set up a policy statement to do this for us, a routing policy. And then we have to go under the protocols RIP group that we created, which was RIP, and export the routing policy into the RIP group. So I know that just sounded like rocket science, but when I break it down for you step by step, we'll do this on each of the routers, and I'll show you exactly what is going on and how to do this. So the first thing we want to do is, let's go to router 6 and we'll start there. So we'll do the command set CLI logical systems R6, and then from router 6 we're going to go ahead and configure, again, we're going to configure a simple routing policy. So if you are not familiar with routing policies and how they work, you can watch my routing policy lab 1, where I give you a great introduction into routing policies, how to create a policy statement with terms. And it's very similar to, if you've worked with the Cisco iOS, it's very similar to creating a route map. So from router 6 we're going to do the command set policy options. Policy statement, and then our policy statement is going to be whatever we want to name it, so we're going to just name it add to RIP. And then our term is, we are going to name the term just T1 for term 1. And you can see that we have the option from. This is where we're going to match. So we're going to match from the protocol. If I do a question mark, we have the statements that we're going to use for this RIP lab. We're going to use direct. So we're going to advertise directly connected routes into RIP. And then we're also going to advertise RIP learned routes to our neighbors. So we need this in order for basic connectivity and our updates to be sent and received to and from our neighbors. So again, set policy options, policy statement, our policy statement name, which is add to RIP, term T1, from protocol RIP also going to do from protocol direct. And so now that we have our match statements within our routing policy, we're going to have to tell the router what to do. We're going to use the then statement, and this is the action to take. So we are then going to, if we look at the very top, we're going to accept the routes. So we're simply going to accept the routes. So it sounds like a lot, but this is what we have to do in order to get RIP to work. Because if we don't do this, then these RIP routes, none of the RIP routes are any of the networks. The 6 network and the 7 network on R6 and R7 will not be advertised into RIP. So we actually have to create a routing policy again to advertise these directly connected routes into RIP and start sending and receiving these routes. So now that we have the routing policy created, now we have to go under the protocol's RIP group named RIP and export this routing policy into our RIP group. And we do this with the following command: set protocols RIP. Then we specify our group that we made, which is predefined, as we can see. If we just do a question mark, you can see that we already have it named RIP. Then if we do a space question mark, you can see that we have the option for to apply an export policy, and that's exactly what we're going to do. We're going to do export, and then if we do a space question mark, you can see that we're going to have to add our export policy name, which is add underscore to underscore RIP. Let's go ahead and commit these changes. We'll go back to the main router, and if I do the statement show route logical system R7, you can see that router 7 has not learned of the 6 network yet. And that is because if we look at router 7, from router 7's point of view, we only have RIP enabled on R6, R8, and R7. So obviously this network's not going to be coming from router 9. And router 6 is only advertising this network out to router 8 right now. So router 8 is not going to be passing this network to router 7 because we have not created an export policy within our RIP group that has the policy statement, the routing policy to advertise these RIP learned routes to its neighbors. So router 6 should be passing these routes to router 8. If we go and do a show route logical system R8, we can see that we are actually learning the 6 network now. However, let's go ahead and try to ping it. If we do a ping logical system, again we are looking at router 8's routing table, we'll try to ping the 6.6.6.6 network. You can see that we have reachability. So let's go ahead and do this. Let's create on logical system. Let's go under edit mode. We'll do the set logical system R8, and then from router 8's point of view, we'll create the policy option with the policy statement of add to RIP, just like we did on R6. We'll create our term T1, and then from protocol RIP. So we'll go ahead and do that, and then we'll leave out the directly connected interfaces from advertising those into RIP. And then let's go ahead and see what happens when we do the term T1 and then accept. So So we're just going to accept riplearn routes and pass them to neighbors. So if I do a commit from here and get out of configuration mode, and if I go and take a look at the routing table on router 7, you can see that router 7 is not learning excuse me, sorry about that. You can see that router 7 is not learning the 6 network yet, and that is because I forgot to go ahead and apply this routing policy to the, let's go ahead and do this. We'll do the command set protocols RIP, or I'm sorry, we'll do the set logical systems, again from R8's point of view, protocols RIP, group RIP. Then we're going to have to export this routing policy to our RIP process. So we're going to export the routing policy named add to RIP, and let's go ahead and commit this. So what we did and why that route wasn't being advertised to router 8 is because we created the routing policy, but we did not apply or export that routing policy to our RIP group. So now that we have committed that change, if I go ahead and do a show route logical system R7, now we can see that we are learning the 6 network via RIP. And again, the route preference for RIP on a Juniper router is 100 by default. And you can see that we have a metric of 3. Again, the hop count is the metric in RIP, and we can see that from router 7's point of view, router 7 sees the 6th network 3 hops away. So we have from router 7 to router 8 1 hop, router 8 to router 6 2 hops, and then from router 6 to the loopback the 3rd hop. So let's go ahead and try to ping from logical system R7. Let's try to ping the 6 network. And then we run into another problem. And if you are familiar with routing protocols and IP routing in general, then you probably understand that why this ping is failing. And that is because from router 7's point of view, it knows about the 6th network. However, it does not know about the 86th network. And the 86th network is not installed in router 7's routing table. And this is because on router 8 we did not advertise the directly connected interfaces into the RIP routing process. So if we were to go and do a show logical systems R8, you can see that we have the policy option, policy statement add to RIP. For term T1 we have from protocol RIP then accept. However, we are not accepting the directly connected interfaces on router 8 and advertising those into RIP as well. So that's why we have a broken network topology and we cannot ping from router 7 to router 6. So let's go ahead and fix this. We'll do the command set logical systems R8, policy options, policy statement, add to RIP. For term T1, I'm just going to add from protocol direct. Let's do a show configuration, or we'll do a, show logical systems R8. And now we can see we have from protocol both RIP and direct. We are going to then accept and export those into our RIP routing process. So these networks, the 86 network, we should see after we do this being advertised, being advertised to router 7. So let's go ahead and commit this. If I do a show route logical system on R7, we now see that we are learning via RIP of the 86 network. Let's go ahead and try to ping from router 7, and now you can see that our ping is successful. Let's go ahead and do a more friendly ping. So we have full reachability now from router 7 to router 6. If I do a show configuration logical system R7, we don't have any policies set up yet on R7. So if I try to do a ping, if I do a ping logical system R7 and source this from the 7 network and try to ping the 6 network, we run into our next problem, and that is that we do not have reachability from the loopback 0.7 IP address on R7 to the loopback 0.6 interface on R6, and that is because on router 7 we have not created our routing policy yet to export our directly connected and our RIP routes into our RIP routing process. So that is our next step in this lab. And we're going to do this just like we did before. We'll do set logical systems R7, policy options, policy statement, add to RIP, from term T1, from protocol RIP, and then also from protocol direct. Once we receive these, we're going to, after we match on those, we're going to do the action of accepting these routes. The next thing we're going to do is set set logical systems R7, protocols RIP from the RIP group of RIP. We're going to export these. We're going to export the routing policy add to RIP to the RIP process. Let's go ahead and commit and quit. And once we do this, what we should see is if we do a show route logical systems R6, you can now see that we are learning via RIP the 7 network. So let's go ahead and try to do what we did before. We did a ping from logical system R7 from the source of the 7 network to the destination 6 network. And now we have reachability. So we'll do a rapid count of 1,000, and you can see that we are successful. So we have fixed the RIP network for now. We encountered several problems, and the last thing that we need to do now is, from router 9's point of view, is enable our routing policy and RIP as well on the interfaces. And that's going to bring up our last topic, which is manipulating the RIP metric. So let's go ahead and do the, under configuration mode, we'll do set logical systems R9. I'm going to go ahead and configure this as like we were just sitting at router 9's command line. So we'll do set CLI logical system R9. Then we'll go under edit mode, not edit mode, configuration mode. And from router 9's point of view, we're going to do set protocols RIP. Again, to enable RIP on the router, we're going to use the group statement and then name our group RIP. And we're going to advertise where we want to speak RIP with, or speak RIP out what interfaces, and that's going to be 96 and 97 from router 9's point of view. So the neighbors are going to be LT120.96 and LT120.97. Once we do this, we have to create a routing policy. So we'll do set policy options, policy statement, add to RIP from protocol RIP and also from protocol direct. So very important that we advertise are directly connected along with our RIP routes. If not, then we're going to have big issues like you saw earlier. So once we match on those two criteria, the RIP and direct, we're going to then accept those routes. And our last step is to do this command set protocols RIP for the group RIP. And we're going to export the routing policy add to RIP to the RIP process. Once we have all this complete, if I do a commit and quit on R9, let's go ahead and get out of router 9 altogether. If I do the command now, show route logical system R6, we now see that in our routing table, to get to the 7 network, we have two different hops, or we have two different options. We have the 86 network and the 96 network. And our router is preferring the 86 network. So again, the 86 network, if we look at our network diagram from router 6's point of view, to get to the 7 network, router 6 is taking the 1.5 or the T1 link across. So this is not desirable, as we all know that a 100 meg connection is a lot faster, or fast Ethernet connection is a lot faster than a T1. We can also look at this route specifically if we do a show route 7.7.7.0 detail. I'm sorry, 7.7.7.0/24 detail. I'm sorry, I'm looking in the routing table. Sorry about that. Show route logical systems. I'm sorry, I was looking in the, I should say, the physical routers routing table, which there is no 7 network, so that's why we got nothing. We look in the correct routing table, which is logical system R6 on the 7.7.7.0 network. We can see that we have learned this route via RIP. Its preference is 100. The next hop that it is taking, we can see that we see two next hops towards this network. The one that is selected has the keyword selected next to it, which is the LT logical tunnel 68. And we see the metric that we have. Again, the metric is the way is hop count with RIP. So from router 6's point of view, it sees this 7 network as 3 hops away. So from router 6 to router 8, 1 hop, 8 to 7, 1 hop, and then locally within router 7 to the loopback is another hop. So 3 hops. Let's go ahead and take a look. If we look at logical system R7, we see that router 7 is using the to get to the 6th network. Router 7 is using the 97 subnet, or its logical tunnel 79. And from our point of view from our map, that makes the most sense, because that is the fastest way that router 7 gets to the 6th network located off of router 6. So that's good. However, we do see that router 6 trying to get to router 7's loopback is using the 86 network, which is indeed the slower path. Again, if we do a show route logical system R6, we see the 7 network is being preferred over the 68 interface. So the way we can fix this is if we go to router 6 and we're just going to give a metric inbound on this logical tunnel interface, or in any case it could be any type of interface, but in this example of course it's a logical tunnel. We're just going to change the metric inbound for all the routes that we are receiving from this neighbor. So we're going to make it larger, and as we see we have a metric of 3 from both of these neighbors, or from both of these paths to reach the 7 network. Again, the way we're going to fix this is by going under Set Protocols RIP. We're going to specify our group, which is RIP. Then we're going to go under our neighbor, and then we're going to go under the neighbor that we want to apply a larger metric inbound. So in this case, the preferred path to the 7 network from router 6's point of view is the 68 link, and if we look at our diagram again, that link is actually our T1, so we want to give that link a higher metric, our hop count. That way router 6 will prefer the 69 logical tunnel interface to get to the 7 network. Because right now if I go ahead and show you this, if I do a run trace 7.7.7.7, you can see that we're using the 86 path to get there. So when this is all said and done, we want to use the 96 path. Let's do the command set protocols RIP and then group RIP for our neighbor LT 120.68. And then if I do a space question mark, you see that we have the option for metric in. So we're going to metric value, we're going to add a metric to incoming routes. And you can see we have any number from 1 to 15. So we're just going to put a higher number, so we'll just use 10 for all the routes we're receiving inbound on this tunnel interface. So let's go ahead and commit this change. And now if I go ahead and run a trace, you can see that it's still taking the 86 network. It's going to take a second for this network to get flushed out of our routing table. And now you can see from our trace we are now preferring the 96 network as our path to the 7. So if we do a run show route to get to the 7 network, we don't see both paths anymore. We just see the 96 being preferred. That is because it now has the best metric, which is the metric value of 3. We have created a higher metric value, manipulated that on the LT68 interface on router 6. If we look from router 7's point of view, set CLI logical systems R7, we do a show routes, we see the 6 network coming in the 97 path, and that is exactly what we want to see. However, if we want to not change this, but we want to make this so that it is always the preferred path, say that you have some RIP neighbor adjacencies bounce and some networks, some interfaces go down and come back up, and the 87 path might be the preferred path. We do not want that to happen. Since both of these paths to the 6 network have a metric of 3, the 87 network are the 78 tunnel IP, the 78 unit, logical unit, could become the preferred path. That is again the 1.5 meg or the T1 link. So let's go ahead and do some good proactive configuration on R7, we'll go ahead and set protocols RIP for group. Again, this is going to be RIP for our neighbor, then our logical tunnel, which is going to be LT78 interface. So LT78, then we're going to apply a higher metric inbound, so a hop count of 10. Let's go ahead and commit this. We'll go ahead and exit. And now if I do a show route, we should see that route being flushed from the routing table any second. We should see this 87 network get deleted. And now we no longer see that. So we see the 97 network as being the best path. Oh man, that was a long lab. Again, apologize for the length of this lab, but it is very fundamental and very important, I should say, that you learn all of these characteristics of RIP. RIP is a very simple protocol in theory, but configuring it on a Juniper router can be very configuration. It can demand a lot of configuration. So you have to create routing policies, you have to influence metrics, you have to go under your protocols RIP group, and if you want to make a metric higher, you have to do the command neighbor metric in and then set the value from 1 to 15 like we showed you at the end. And again, under your routing policy, it's very important that you advertise the correct protocols into your RIP routing process. By default, RIP will not, on Juniper routers, will not advertise any of these networks into the protocol. We have to go in, create a routing policy, and say specifically that we want to add from the protocols of RIP and direct, and then accept these. Then we have to apply our routing policy as an export statement under our RIP group. So there's a lot of configuration going on just to configure RIP. And even though RIP might be an older protocol, it's still being used on networks today, and it's very important that you learn how to configure RIP, because you never know when you're going to see it in a production environment, and a lot of people will want you to know exactly how to configure RIP, because it is very important. Obviously, other protocols such as OSPF, ISIS are more common and preferred because of speed. But RIP can still be used in a lot of out-of-band networks, management networks, and other very low latency, very low bandwidth type networks. So thanks for watching this video, and I hope to see you in the next one.